Welcome, viewer, to part 5 of the TitanBot series. In this episode, we will be building the Kinematic Logic Tray. This is going to connect into the vertical frame rail, and it forms the second level for our TitanBot. When we're done, we will have a part that has tabs that connect to the indexing slots in the vertical frame rail, and also has 4 mounting spots to produce redundancy and rigidity to the overall design. Alright, so let's get started, and we'll begin by creating a body and a sketch on the XY plane. And this is a symmetric part, so we're going to use the polyline tool, and we're just going to create a part with 3 tabs. We will modify the horizontal and vertical constraints on these tabs here when we're done. So rough out a shape that looks something like this, and don't forget to close your shape. Right click to clear your tool. Now we're going to fix up any non-horizontal or vertical parts. We have quite a few here. And now that we've done that, oh, we got one more there. Now that we've done that, we are going to make the bottoms of the tabs. So we're going to grab the vertices at the bottom of these tabs, and we're going to make them collinear. So select them all and constrain horizontal. And now we're going to make the tab tops so that they are also collinear. We can do that by just grabbing one side from each one of our tabs and setting the height of the tabs equal to each other. So now when we grab the top of one tab, all of them should move. We're going to set the tabs so that they are equal in width. So select all 3 and set them equal. And now we're going to set these 2 middle gaps here between the first and third tabs. We're going to set them so that they have an equal width. So we've now mostly constrained our shape here. Oh, and we're going to set these 2 outside spaces. We're going to set them so that they're equal. All right, so now we have a symmetrical design, and the tabs will sit symmetrically. So let's make the entire design so that it is symmetrical with respect to the y-axis. So there we are, and now it's time to constrain our shape. And we're going to get rid of some of these parallel constraints, these equal constraints. We will just hide these from our sketch, and that allows us just to work with the sketch. Okay, so we're going to begin by setting the width between tabs to 22 millimeters. We're going to set the height of the tabs to 3 millimeters. This will interface nicely with the vertical frame rail. We're going to set the width of the tabs to 10 millimeters. And finally, we're going to set the overall length of the tray. We'll set that to 94 millimeters. And we have 1 degree of freedom. We need to set the overall height. So we will set this to 29 millimeters. Giving us an overall width of the tray of 64 millimeters when it's being mirrored around the x-axis. All right, so we're fully constrained here, so we can close this out. And we're going to pad this shape out to 3 millimeters. Now that we've done that, we are going to mirror this shape. So select on that last pad in your outliner there, and we're going to click on the mirrored tool. And in the panel for the mirrored tool, let's click on the plane selection box, and let's choose select reference. Let's zoom in on the edge of our tray that we're creating. We'll select the edge that runs parallel with the x-axis there, and we'll press OK. So now we have our mirrored part, and we're going to add some features to this part now. So left click on the top face of this part, and the first thing that we're going to do is we are going to create a couple of mounting holes for the Arduino Uno that's going to sit on top of this. So we're going to create 2 holes to begin with. one here in the lower left, and one in the mid right-hand side. Both of these holes are going to be the minor diameter of the PT screw that we're going to be using to hold the Arduino in. So let's select both. We'll begin by making the diameter equal of both those holes. And we'll set the diameter of the hole to 2.8 millimeters because that's the minor diameter of our PT screw. That's just a thread forming screw, pretty standard for plastic. And now we're going to reference the left-hand edge here. This left-hand edge will be where the side of the Arduino's is that has the USB port and the power barrel jack. So that's going to be what I'm calling the front of the Arduino. And we're going to position that first screw with respect to this edge. So we will set it so that it's 29 millimeters away from the left edge. And we will set this screw so that it is 5 millimeters from the bottom of our tray. So this is the side closest to our front frame rail. Now that we have that one screw there, we're going to position the second screw hole in relation to this first one. These measurements come from the Arduino itself. So I just took a reading off these holes and came up with this set of measurements. Okay, so 52.25 millimeters distance between these holes, and we need to set the vertical offset now between these two holes. That's going to be 32.5 millimeters. All right, so we've got the two screw holes that will be used for securing the Arduino created, and now we're going to pocket these. Our next step is to create standoff bosses. The through-hole components on the Arduino Uno have a tendency of creating torsional stress on the Arduino Uno when you are trying to screw it down. So these standoff bosses will ensure that the board doesn't twist when we are doing the screws up. It gives it a nice flat datum plane to work with. So we're going to reference those two holes that we just made earlier. Those are going to be the center of our bosses. And we're going to begin by creating a circle that is coincident with our existing holes. And now we're going to create two more circles. These are going to be the outer shell of the boss. And we're going to set these two so that they are equal in diameter. And we're going to give it a diameter of, we'll do it on this one up here, give it a diameter of 5.5 millimeters. All right. Now we need to create two more standoffs. We'd only need two screws to hold the Arduino to the tray, so these ones are just going to be standoffs that have pins that will help position the Arduino over top of the screw holes. We're going to set the diameter of both of these to the same. And this hole here on the top left of the Arduino is offset from the one on the bottom left by 2 millimeters. So we'll give that a 2 millimeter offset. That hole is offset to the inside of the Arduino. And it's separated from the bottom left hole by a distance of 48.75 millimeters. And we're going to give these holes a diameter of 4 millimeters. And we just need to constrain the bottom right boss. So we're going to make it so that it is vertically aligned with the hole above it. And this is going to be separated. These two holes are separated by a distance of 28 millimeters. All right, so these form the outlines for the bosses we're going to create, and so we're going to pad these out to 3.5 millimeters. And now we just need to add the locating pins to the top of these two additional bosses that we created. So we'll create a sketch on the top of one of them. We'll use our external geometry tool to reference the top of these bosses. And we will use the circle tool to add pins to the top. So there we are, two circle shapes. We're going to set them equal in diameter to each other. And we will set that diameter to 2.8 millimeters. And with that, we fully constrained the pins, and we will pad those out by 2 millimeters. All right. Now what we're going to do is add some anchor points on the ends of this tray that will allow us to add some structural redundancy to the vertical frame rails. These tabs do a pretty good job of interlocking with the vertical frame rails, but they do wear over time and become loose. So we're going to add 4 attachment points that will keep it so that the tabs don't release while the robot is in operation. So we're going to reference the left and right hand edges of this tray, and we're going to use the create rectangle tool, and we're going to create rectangles in the extreme corners of our tray here. And we're going to easily constrain the rectangles using the constrain symmetry tool. We'll constrain them with respect to the X and Y axis. And this allows us to set 2 measurements on one of these rectangles and have that applied to all the rest of the rectangles that we're creating. Okay. So now that they move in a symmetrical manner, we're going to set the width of these tabs to 9 millimeters, and we will set the height of these tabs to 6 millimeters. And with that, we have fully constrained this sketch so we can close out of it, and we are going to pad them out to a height of 6 millimeters. All right. So now we're going to add the pockets for the PT screws on these tabs that we've just created. So we're going to begin by creating 2 circles, one over each tab, and we're going to constrain these 2 circles so that they're symmetric with respect to the y-axis. So I'll try that again. Click the center of both. I just went Control Z there and redid that. Okay. We're also going to set the diameter of both of these screws so that they are equal. And now what we're going to do is we're going to focus in on just the left-hand side screw here. So again, this is the minor diameter of the screw. It's the size of the shaft on the inside part of the screw where there are no threads. We'll set this to 2.8 millimeters, and we're going to reference the top edge of this tab, and we're going to position this screw so that it is 4 millimeters from the top, and we'll make it so that it is 4.5 millimeters from the edge. So now our screw holes are fully constrained, and we can now close out of this sketch, and we will pocket those. They're 6 millimeters thick, so we need to pocket them to 6 millimeters to clear the tabs, and we need to repeat this process for the tabs on the other side. So again, two more circles, constrain them symmetric with respect to the y-axis. Set the diameters of each circle so that they're equal. Reference the top edge of the tab. And then take and constrain the circles so that they're sitting in the middle of the tab at 4.5 millimeters, and that they are sitting 4 millimeters from the top of the tab. Last thing that we need to do here is constrain the diameter of this. So again, that is a diameter of 2.8 millimeters, and both of our circles are now fully constrained, so we can close out of this. And again, we will pocket these to 6 millimeters. All right, so we've now completed these tabs that will provide the vertical frame rail with some structural redundancy and make it so that the tabs on these trays, both the battery tray below and this kinematic logic tray, will not release during the robot's operation. Next thing that we're going to do is we're going to add some cable management features to our tray. So we're going to create some cable tie points for zip ties. So add a new sketch, and we're going to do this by creating 3 rectangles. So we're not adding 4 because we don't want to put one of these in the front of the USB plug on the Arduino, so we've got to be careful about where we're putting this. Okay, so we're going to make it so that these rectangles are symmetric with respect to the y-axis. The ones on the right-hand side are going to be symmetric with respect to the x-axis. We're going to make sure that all of these rectangles have the same width and height. So there we are. And I'm just going to hide these constraints so that we can add our additional constraints for our lengths here. All right, so now we're going to set the length of these tabs to 10 millimeters. And we're going to set the distance between the 2 right-hand tabs to 12 millimeters. And we're going to set the distance between the left and right sides to 82 millimeters. And we've got 1 degree of freedom left, so that is, we need to set the width of our tabs. So let's set that to 3 millimeters. All right, with that, our sketch for these wire or these cable management tabs is fully constrained, so we can close out of this now. And we are going to pad these out to 8 millimeters. We can confirm, yep, 8 millimeters. All right. So now we're going to add the holes in these tabs so that we can put zip ties through them. So we're going to add a sketch at the front of these tabs. And I'm going to grab the circle tool, and I can take advantage of the y-axis here, so I will make these 2 circles so that they are symmetrical with respect to the y-axis, and I will make sure that both of them have the same diameter. So I can just focus on one of these holes here. So I'm going to use the external geometry reference tool to reference the left and right hand side of the tab. I'm going to set the diameter of the other hole to 4 millimeters. And I'm going to use the constrain symmetric tool to position this hole right in the center of this tab. So we're fully constrained here, and I'm going to pocket those. They're 3 millimeters thick, so our 5 millimeter default clears it. We're going to rotate around and do the singular tab on the other side in front of the Arduino. So grab our circle tool, again, set its diameter to 4 millimeters, reference the left and right edges, and make it constrained in the center of that tab. Our constrain symmetric tool. All right, and so we can pocket that now. And now we have our cable management standoffs complete. We're going to give it an aesthetic touch here. We're going to give a fillet to the edges of these cable tie mounts that we just created. And we will fillet those to 4 millimeters. Oh. Let's try that again. There we are. Clicked the wrong button last time. All right, there we go. So 4 millimeter fillet, and now continuing on with the design language that we used for the vertical frame rails, we are going to add a triangular lattice in the center of our kinematic logic tray. This will help in part with some amount of cooling, but it also just maintains that look and feel that we've established so far with the robot. So we will add a new sketch to the top of this, and we're going to use the polyline tool, and we're going to create 4 triangles. It's a slightly different pattern than we used before. Again, we will clean up the horizontal and vertical constraints here. Let's do that now. So we will clean up our horizontal constraints first. And it looks like our vertical constraint, we have one here that needs to be fixed. There we are, so our vertical constraints are fixed. Now we're going to make the points of the bottom of our triangles so that they are collinear. I constrain them horizontally. And now we're going to modify the spacing between these triangles. So we're going to toggle on our construction geometry and grab the Create Line tool. And we will create lines between the top points of these triangles. And then we will make sure that they are also constrained horizontally. And we're going to set the length of these construction lines so that they're the same. And we're going to make sure that the bases of the triangles are equal in width. And we're going to set the hypotenuse of each of these triangles so that they have the same length. So it looks like that was an over constraint there, so I undid that. So now what we're going to do is we're going to reference the bottom of one of these tabs here, and we're going to make the top of our left-hand triangle so that it is vertically aligned with one of the points there. Let's try that again. Okay, so grab these 2 points here, and we'll make sure that they're vertically aligned. Good. And now we've got a lot of constraints that are sort of making it difficult to see any more information. So we're going to hide our existing constraints, and that will allow us to just view the distance constraints as we add them in. So let's set the width of our triangles to 26 millimeters. And let's make the triangles so that it's symmetric with respect to the x-axis. And let's set the width of our construction geometry to 5 millimeters. And we're going to bring the edge of the triangle in. I'm going to set the height. Set the height of the triangle to 37 millimeters. And we now have fully constrained lattice here, so we can close out of the sketcher, and we're going to pocket these shapes. Okay, so now we've added a triangular lattice to the center of our kinematic logic tray. And the next thing that we need to do is add a couple of shell anchor points on the edges of the trays. We will later on add door panels and attach them at these points here. So we're going to reference the left hand and right hand edge of the tray here, and we're going to grab the rectangle tool, and we'll create 2 rectangles that we will make symmetric to the x-axis. This one never got attached to it, so we will make it coincident there. And we will set it so that it is symmetrical. All right, so there we are. We'll do the same thing over here. We'll make this one symmetrical with respect to the x-axis. And now we're going to make it so that both squares are the same length and that they are the same width. Okay, so now we've done that. I'm just going to hide some of these constraints. Actually, this is fine just like this. All right, let's set the length of this now to 8 millimeters. And let's set the width of these to 3 millimeters. So that's enough to fully constrain these anchor points for the shell. So we can close out of this now. And we're going to pad these out to 4 millimeters. Now that we've done that, we need to add some holes in both of these tabs. So we'll create a sketch on the surface of that tab. Using the circle tool, we will make a circle that's coincident with the y-axis. We will set the diameter of this circle to 2.8 millimeter to accept a PT screw. And referencing the top of this tab, we will set it so that it is 2.5 millimeters away from the top of our tab here. So there we are, 2.5 millimeter distance. We can pocket this hole now at 3 millimeters, and we will do the same thing on the other side. And again, we're just going to grab the circle tool. We will constrain this to 2.8. We will reference the top of the tab, and we will set the distance of the circle from the top of the tab to 2.5 millimeters. All right, so with that, our circle is fully constrained. We can pocket it through the tab, and we now have a fully complete tray.